Place the following numbers in order, starting with the smallest. Okay, so what do we have? We have 1.5 for 3 over 2. We got 1.4 for obviously 1.4. Then root 2, I think, is 1.414. So 1.414. So that to me means, starting with the smallest, it's going to be 1.4, root 2, and 3 over 2. Which of the following was not a rational number? Explain your answer. Just pi, and I'll explain the reason why. Any of them can be expressed as a fraction. 3 and 1/7 is 22 over 7. 3.142 is actually 3,142 over 1,000. That's a fraction. 22 over 7 is a fraction, and the only one that isn't a fraction is pi. Okay, pi, as it cannot be expressed as a fraction. Okay, so you put pi in your calculator, shift pi, you see it doesn't change into a fraction. It's a decimal that never ends. Okay, and there's no pattern in the decimal. Okay, question 2. John thinks that he has a method for finding all prime numbers. Now please remember what prime numbers are. Prime numbers are, 2, 3, 5, 7, 11, 13. Numbers that have factors of only themselves and the number 1. Okay, so that's important. That's 11 by 1, and this is 13 by 1. So let's see what he's trying to do. So whatever p is, multiply by 6 and add on 1. So he has 1, 7. 2 times p plus 1 is 13. 3 times p plus 1. 6 times 3 plus 1 is 19. Just keep adding 6's. 25. Now that's not a prime number. And then 31 is a prime number. Okay. 1 second. Okay, so then next one is 6 times 1 plus 7, which is 12. 6 times 2 plus 5, which is 17. 6 times 3 is 18 plus 5 is 23. 6 times 4 is 24 plus 5 is 29. And next one is 35. 6 times 5 plus 5 is 35. Give 2 reasons why this method is not fully correct. Well, reason 1 is, I suppose 25 is not a prime number. Also skips 2, does not generate 2. Generate the number 2, which is prime. And also the number 1 is not prime as well. So 1's not prime, 12's not prime, 35's not prime, and 25's not prime. So there's a lot wrong with it. Okay. So next, we're moving on to the next question. The Swiss mathematician and physicist Euler first noticed that in 1772 that the expression n squared minus n plus 41 gives a prime number for all positive integers of n less than 41. Explain why it does not give a prime number for n equals 41. Well, what we can do is we can enter in replace n with 41. So it's 41 squared minus 41 plus 41. Basically replacing n with 41. And then we get 41 squared, which is 1,681. The other 41s cancel. But this has factors of, it has factors of 1 multiplied by 1681, and also has 41 multiplied by 41. And so 1,681 is not prime, as it has 3 factors. It's only meant to have 2 factors itself and 1. Okay. Now, let's move on. Question 3. Complete the Venn diagram. Alright, so 4 in the middle, they all have 4 in common. A and B have 2 and 6 in common. So 2, 4, and 6 gone. 2, 4, 6 gone, and 4 gone. C and B have 8 in common. A and C have nothing in common bar 4, so this is empty. This leaves 3 and 5. And then C is left with 1, 12, and 14. Okay, what is A intersection B? Well, that's 2, 4, and 6. Everything that's in between A and B, that's in both of them. Okay. Next one. Everything in B that's not in A intersection C. So everything in B is all this. Also, keep forgetting that B also has the number 10 here. But you're not allowed to be in A intersection C. So you're not allowed to be in this region here. Oh, sorry. You're not allowed to be in this region here. So we got to leave out the number 4. So it's just going to be 2, 6, 8, and 10. So 2, 6, 8, and 10 there. Okay. Everything in B that's not in A, union everything in B that's not in C. So let's do everything in B that's not in A. So everything in B that's not in A. So everything in B that's not in A is 10 and 8. Everything in B that's not in C is 2, 6, and 10. And it's OR, so it can be either of them. So the answer is 2, 6, 8, and 10. You're allowed to have both of them. Okay, so 2, 6, 8, and 10. And this is also 2, 6, 8, and 10. Write down a null set. So this is the null set right here. So what it is it's A intersection C, but you're not allowed to be inside of B. Because A intersection C would be this part here, but then if I exclude the B part, what I have left over is just this green part here, which is the part I'm looking for. Okay, so that's that done. Okay, let's move on. So what have I done so far? 1, 2, and 3. Now we're on to the next question. Maxes and mins. So this is going to be fun. 1, 2, and 3. Find with the aid of a Venn diagram the minimum number of questions answered correctly by both teams. Okay, team M answers 72 questions. Okay, so we're just going to toy around with this for a minute. So what I'm going to do is I'm going to make another one of these in the corner. And I'm going to show you what we're going to do. Okay, so we have M and N. Now, find the minimum number of questions answered correctly by both teams. All right, so let me find out. So 100 questions in total. So if we put 72 here and 38 here, we know that's too much because it adds to give you something over 100, okay? So let's toy around with some numbers we can put in here. What happens if what happens if we put in the number 10 as an example? So that could be 62. Oh wait, I got it right already. So that could be, if you put 10 in the middle, that would put 62 here, and that would put 38 here. Right, and that's too large because add them together. 62 plus 10 is 72. Oh, sorry, not 38, 28, because you take it away. And what happens when you add them all together? 62 plus 10 plus 28, that will give you 100. Basically, the way of thinking of that is, imagine that you put the outside as 0. If you put the outside as 0, that means that you're going to have x in the middle, and that'll be 72 take away x, and that'll be 28 take away x. And then what you can find out here is that all these regions have to add up to 100, so 72 take away x plus 28 take away x has to equal 100, and then the x's cancel, leaving you 100 and, oh sorry, that's 38. keep forgetting. It's 38 take away x. So that'll be 110 take away x equals 100 and x equals 10. Okay, so that'd be one answer, that you set that as 0. All right. The second extreme is where they have every answer n answers it has in common. So all 38 questions n answered, m also answered. So in a case like this, what you can say is that this is 38 goes in the middle, and this one makes then 72 take away 38 is 34. 34 for m. So m adds up to 72 and n adds up to 38, and then on the outside you get 28 questions wrong. Okay, and this will be the minimum amount of questions answered correctly by both teams. So this would be 28, this would be 34, and this would be 38. And then in the other question we said was 10 in the middle, and you have 62 here and 28 here and 0 here. So the maximum number of questions answered correctly by both teams would be 100. The minimum amount of questions answered correctly by both teams would be 71 or 72. Okay, and we're done. So that's 1, 2, and 3. This one is question 4. So 1, 2, 3, and 4. Factorize fully this one. Now, the 9 leads to 6 and the 12 leads to 8. I think we don't have to do anything with this one. It's going to be 3a into 3a minus 2b. And then it's going to be 4c into 3a minus 2b. Remember to multiply it back out. Check and multiply it back out. And then we're going to get 3a plus 4c. 3a minus 2b, and once again you can multiply that back out to check your answer. This one's the difference of two squares, where it's going to be 3x 2b squared gives you 9x squared, because 3x multiplied by 3x is 9x squared. Same thing for 4y. Difference of two squared, so it's going to be 3x plus 4y and 3x minus 4y. Okay, the next one, use factors to simplify the following. Well, on the top one, I can just take out 2x and I get 2x into x plus 2. On the bottom one, I'm going to have to use the reference number technique. So 2 multiplied by minus 6 is minus 12. And then what we're going to get here is two numbers that multiply to give me minus 12, but add to give me plus 1. 4 and minus 3. 2x squared plus 4x minus 3x minus 6, 2x into x plus 2, minus 3 into x plus 2, 2x minus 3, and x plus 2. Okay, then you got to strike off what are the same top and bottom. The 2x plus 2's are correct, are the same. See, everything's been multiplied because there's nothing in between the brackets. So it's like me saying 5 multiplied by 3, and then the other one is 7 multiplied by 3. I'm just cancelling the 3's, okay? Now, I'm not allowed to cancel the 2x's at the end, and here's why. Some people be inclined to try and cancel the 2x's. Get an example like this. What's 5 over 5 plus 7? That's 5 over 12, but you're not allowed to just cancel the 5's into 1. Then the answer would be, I don't know, 1 over 8. So please remember, multiplication you're allowed to cancel, addition or subtraction you're not. Okay? When it's not being multiplied by everything on the top or the bottom. Okay, so that's 4 done. So 1, 2, 3, 4, now we're on to 5. Okay, so there's two parts to this, less than or equal to 1 minus 3x, and then the other one is 1 minus 3x less than or equal to 13. Less than or equal. So move the 3x to the left, the 17 to the right, so we get 3x less than or equal to 1 plus 17. 3x less than or equal to 18. Then divide by 3, x less than or equal to 6. Now move over to 1, so you get minus 3x less than 13 minus 1, which is 12. Multiply both sides by minus, you get 3x, but you got to change direction to make it greater than minus 12. Then divide by 3 and you get x is bigger than minus 4. Now it's x element z, which means positive and negative whole numbers. So we're not allowed minus 4, but we're allowed 3 minus 2, and we're allowed to go all the way up to 6, and including 6 because of the equal sign. Okay, and we're done. Okay, question 6 is about it's an unusual one. It's in the area and volume part. All right, now when the cross section, when the surface area stays the same throughout the object, it means that it's going to have a constant rate of loss, or sorry, its height is going to be gained at the same rate. So it's like when you fill a glass. So example is, if I put water in it, if I put the same amount of water into a thin glass and a really wide glass, in the thin glass the height rises up really fast, but in the really wide glass the height is doesn't rise up fast at all, because the water is spread amongst a wide area. Okay, so they're actually both, let's say for example, they're both 50 milliliters of water, but one of them is a considerably higher level of water than the other one. Depends on the size of the section. All right, so in this case, in case number 2, the section is always the same size. So this means that it's going to increase at a constant rate. So A is going to be 2. So graph container 2 is A. Now in container 3, we see two distinctly different objects. We see a wide cylinder and a narrow cylinder. On the narrow cylinder there, the height is going to increase quicker when you're pouring in the same amount of water compared to that of the wide cylinder. So it's going to be two completely separate sections. So that's why question 3 is going to be B. And that leaves the last one, which is going to be 1C. The height rises quicker as time goes on because it's narrower at the top, which means that the height is going to increase quicker towards the end. Okay. Now, all right, now this is the exact opposite. This is where the height increases rapidly at the start, but then the area gets bigger at the end. So it's going to increase rapidly at the start, but then it's going to peter off and it's going to get slower, like this. Okay, and that's your graph. Now, so what do we do? 1, 2, 3, 4, 5, 6, and now 9. 2, 3, 4, 5, 6, and now we're doing 9, because 9 has a bit of has the line in it, and then it has some algebra as well. So we got to cover this just to be certain. Okay, I'm going to make this a bit smaller, much smaller in fact. That's the least important part. Now question 9. Okay, so we're doing amount in sterling, and then we're doing cost. Okay, so what points do we have? We have 20, 33, 40, 56, 60, 79, 80, and 102. 20, 24, 40, 48, 60, 72, and 80, 96. So let's start off with the red boxes. So 20 and 33. Now which one's the sterling amount? Sterling is on the left, euro on the right. So 20, 33 will be roughly there. 40, 56 will be just above halfway between 50 and 60. There. 60, 79 will just be under the 80 mark. So 60, 79, just be under that mark. And then 80, 102 will just be above the 100 mark there. I think we have a straight line for that one. Yeah, very close to straight. Now the next one, which we'll do using green dots. 2024, just there. 4048, just there. 6072, just there. And then 8096, just there. So you can see the second line just staying underneath it, like so. They both have different slopes. Now one of them has a slope of, if you look at it, for every 20 sterling, for every 20 pounds, we're getting an extra, what is it, 23 euro. So that means one sterling is going to be, what's 23 divided by 20? €1.15. So the slope is 1.15 there. And then the slope for the other one is every 20 is going to get us 24. Every 20 euro gets us every 20 sterling gets us 24 euro. So that means £1 is going to be 24 divided by 20, which will be €1.20. So one of them's one euro sterling to €1.15, and one sterling to €1.20. So the slopes look parallel, but they're not. They're just very close in value. One has a slope of 1.15 and the other one has a slope of 1.2. So they're very close, but they're not the same. Okay, what's the next thing it wants from us? Use your table, find the slope or rate of change of the graph. Explain what this value means. Jack's graph. So which one's Jack's graph? Jack is so what we're going to use 20, 33 and 40, 56. We'll use the first 2 points. 20, 33 and 40, 56. Difference of the y's over difference of the x's, which ends up to be 56 take away 33 over 40 take away 20, which is 23 over 20, which is €1.15. You could say it's the currency exchange rate. Right, where £1 is worth €1.15. Write down a formula to represent what Jack must pay in euro for any given amount of sterling. State clearly the meaning of any letters that you are using. Okay. So let's do this. Now, there is a problem with this, all right? We'll show you the problem. Is when you so let's say you pay 40 sterling. 40 sterling turns it into 56, okay? So 40 should turn into 56. So look at this. 40 should turn into 56. But multiply 40 by 1.15 and you get 46. But yeah, there's 56 there. So we can see we're 10 short. Okay, and let's have a look at another one. Let's look at 60 turned into 79. So let's have a look at 60 turned into 79 there. So it's going to be 60 multiplied by 1.15 if this works correctly. It's 69, it's 10 short again. So there is a little part here that we have to consider. And here's what we got to consider. We actually got to go backwards with the line here. You see we're missing 10 every time. So when we go back to the line, we end up starting on 10. So our formula is actually different. We're going to have to find the equation of the line here, where y is the amount of sterling and x is the amount, y is the amount in euro and x is the amount in sterling. Is that okay? So y is the amount of euro, x is the amount of sterling. So let's find out what's going on here. Okay, so there is an issue. So we're going to use 2 points. We're going to use any 2 points on Jack's graph, so 40 and 56. I suppose the other point we could use is 20 and 33. We can use any points on Jack's graph. Okay, we already know the slope is 1.15, so it's y minus y1 equals 1.15 into x minus x1. So what we're going to have is call this one x1, y1. So it's going to be y minus 33 equals the slope, which is 1.15 into x minus 20. Y minus 33 equals 1.15 times x. Now 1.15 times 20, 23. Bring it all over one side, so y equals 1.15 times x, and it's going to be minus 23 plus 33, which is plus 10. So y is the amount in euro, and x is the amount in sterling. So that's your equation. It gives you the amount in euro is multiply 1.15 times the amount in sterling, add on your 10. Write down a formula that would represent what Sarah must pay in euro for any given amount of sterling. So in Sarah's one, we're going to have to find out, so 2 points we're going to use are 20, 24 and 40, 48. 20, 24 and 40, 48. We find the slope first using the slope formula. So y2 take away y1 over x2 take away x1. I think we already know it's 24 over 20, which is 1.2. And then we're going to use the equation of the line formula. And then we're going to get y minus 24 equals 1.2 into x minus 40, or so x minus 20. Now 1.2 times 20, 24. Okay, and in this case we can see that the 24s are going to cancel each other. So we're just simply going to get a value of y equals 1.2x. And we're just going to use the same letters as last time. Y is the amount in euro and x is the amount in sterling. So we can just reuse that down here for this formula. All right. Okay. Now, using our formula, otherwise, find the amount of sterling Jack and Sarah could buy that would cost the same amount in euro. So both formulas equal each other. Essentially, you're getting the same amount of sterling for the same amount of euro. So one of them is y equals 1.2x. The other one is y equals 1.15x plus 10. So what we're basically saying is the amount of money is the same. So essentially, the amount of euro, which is y, equals in both cases because you're using the same amount of sterling, which is x. So it's going to be 1.2x equals 1.15x plus 10. Then we're going to go 1.2x take away 1.15x, which is 0.05x equals 10. Then we're going to divide 10 divided by 0.05, which will be 200 sterling, I believe. Yeah, 200 sterling when you put that into the calculator. Okay, so 1 to 6 and then 9, and now we're on to 10. 2, 3, 4, 5, 6, 9, and 10. Okay, so algebra slash graphs, okay? Now, the deal is with roots is that it's an n-shaped curve when it's a minus x squared. You could also just throw it into the function. You could throw it into the table function of your calculator and match up the points if you forgot that. So minus x squared, take away 2x plus 3. Start at minus 4, end at 2. And you can see that the equations match there. Minus 2, 3. We got 0, 3, which is there. Okay, so that works perfectly. So this one is g of x, and this one here is f of x. Okay. Next thing, we see two functions here. Both are u-shaped. And what we're going to be asked is write down the roots of each function. So the roots of h of x is where it crosses the x-axis. So we have x equals minus 2 and x equals 3. Now to find the equation, we go back a step, so move the 2 over the other side. So you'd get, what's it, x plus 2 equals 0 and x minus 3 equals 0. So that's going to be x plus 2 and x minus 3 equal to 0. And then you can multiply that out. That's an acceptable answer right there, but if you multiply it out, you'll get x squared minus 3x plus 2x minus 6, and this will be the equation x squared minus 1x minus 6. And that's your equation there. Okay, same deal for k of x. We have x equals minus 3, and then we have x equals plus 2. So then it's the opposite way around this time. It's going to be x plus 3 and x minus 2 equals 0. Oh, sorry, like that. Because you can blame x plus 3 equal to 0. You can blame x minus 2 equals 0. And now you're going to find out the equation. So it's x times x is x squared. X times minus 2 is minus 2x plus 3x. Take away 6, and this graph is x squared plus 1x minus 6. Okay, so we're done. Now we're on to question 11. So that's question 10. This one is question 11. X is a real number. One known number is formed by increasing x by 1. Increase x by 1, it's x plus 1. Decrease x by 2, it's x minus 2. The product of these two numbers equals 1. So product means multiply them together and put them equal to 1. Solve this equation, you multiply it out. X times x is x squared. X times minus 2 is minus 2x. 1 times x is 1x. And then 1 times minus 2 is minus 2. Bring the 1 over the other side. Minus 1 equals 0. You're going to get x squared minus 1x minus 3 equals 0. A hint here is the fact that it wants it to decimal places. This means we're going to use the minus b formula. So our a value will be 1. That's what comes in front of the x squared. B value is minus 1. Minus b value is plus 1. C value is minus 3. Then what we're going to get is put all this into the calculator. So we're going to get minus b, which is 1, plus or minus the square root of minus 1 squared minus 4 times 1 times minus 3 all over 2 times 1. Put that into the calculator. Make sure you press the fraction button first. Fraction button. 1. I'm going to do plus first. So it's minus 1 squared minus 4 times 1 times minus 3 all over 2 times 1. You get an answer of 1 plus root 13 over 2, which is 2.3. Correct to 3 decimal places, so 2.3, 27 rounds up to 30, so 2.303. Or go back, change it to a minus. Minus 1.303, once again 27 rounds off to 30. Okay, I believe we're on to question 12 and then 13. Let's keep going. 12, simplify the following. Okay, 12x squared minus 6x minus 6x plus 3. I believe we're going to be left with 12x squared minus 12x plus 3. Okay. Part B, simplify the following. This is a long division. So it's going to be 3x cubed minus 2x squared minus 3x plus 2. And what we get is x minus 1. So x into 3x cubed, so it's basically 3x cubed divided by x. Cancel, it turns into 2, so it's 3x squared. That's the division part. Now we're going to multiply 3x squared by x and minus 1. So what we get is 3x cubed minus 3x squared, but then we got to do a subtract it, and that means change the signs of any negatives. Minus 2x squared plus 3x squared is 1x squared. Drop the minus 3x. This time we're doing x squared divided by x, which is equal to 1x. Multiply the 1x out and we get x squared minus 1x. Change the signs. Minus change to plus, so it's minus 2x plus 2. Now we're going to divide minus 2x by x and we get minus 2. Multiply it out and you get minus 2x plus 2, but then you got to change the signs into positive and negative and it comes 0. So your answer is 3x squared plus 1x minus 2. Okay. Now we're on to part C. Solve the simultaneous equations. Well, I'm going to multiply the top one by 3. And I'm going to get 6x minus 9y equals 54. 5x plus 9y equals minus 10. 11x equals 44. X equals 4. Sub it in either to equation A or equation B. I'll use equation B. 5 times 4 plus 9y equals minus 10. 20 plus 9y equals minus 10. Bring the 20 out the other side and we get 9y equals what's it, minus 30, because minus 10 minus 20 is minus 30, and y equals minus 30 divided by 9, which is the same as minus 10 over 3. Okay. Verify, I think next part wants us to verify an answer or something like that, so let's see what it wants from me. Oh, I don't seem to have it here. C part 2. Verify your answers to C part 1. Well, we can check both of them. You might as well just check both of them. So 2x minus 3y equals 18. It's the first one you're going to check, and then the next one is 5x plus 9y equals minus 10. So you just plunk in your numbers here. So x is 4, so 4's go here, and then y's is minus 10 over 3. Minus 10 over 3. So this one's going to be 8 plus 10 equals 18, and 18 equals 18. So this one is verified. And then the second equation, which is going to be 20, and then 9 times that is minus 90 over 3, which is minus 30. And then minus 10 does in fact equal minus 10. So this one is verified. Okay. Let's keep going. Question 13. Use the diagram to calculate the value of x. Give your answer in third form. Well, x squared equals 3 squared plus 3 squared. X squared equals 9 plus 9, which is 18. X equals the square root of 18. Three root 2, which is 4.24. Oh, in third form. Excuse me, I made a mistake there. 3 root 2. Next one. 3 squared equals 1 squared plus y squared. 9 equals 1 plus y squared. 8 equals y squared. Square root of 8, and you get 2 root 2. So it's 3 root 2 and 2 root 2 for x and y. Move on. The rectangle with lengths x and y is drawn using the values of x and y as shown. So y was 2 root 2 and x was 3 root 2. Find the perimeter of this rectangle in the form. So the perimeter is just add all the sides together. So this should be quite easy. So it's 2 root 2 plus 3 root 2s plus 2 root 2s plus 3 root 2. You can use your calculator if you want, but there's no need. It's just 10 root 2s. It's like 2x plus 3x plus 2x plus 3x. Get you 10 root 2. Alright guys, that's question 13, and that's me out of here. Took 41 minutes.